Cool, thanks Dan, and good morning everybody. This is a bit of work that was done after the cyclone really, and I'm just a small part of the larger team that implemented this work, and I found out last week that Josh had to be away this week. He got called off, so I got the short straw. So if you've got any hairy questions, I'm just going to pass them on to Josh. So soon after the cyclone, the question was, especially around the productive land in Hawke's Bay, around the cropping, was what do we do about the silt? And yesterday we heard about what happened in the apples, like what do you do in apples and perennial crops? And that same question was around the vegetables and the cropping side. What do you do? What's the next in the process? What do you plant? When do you plant it? And how do you grow it? So that was a question that came up, and so we worked at getting some a way of proceeding, and we were able to get some funding to have a look-see at this. And our question was like, which crops can you establish and will perform well under silt after this deposition event that occurs? And there's many different ways that you could answer this question. And the way that we decided to look at it was ask this question, or propose this idea that the survivability of a crop depended on the size of the seed and how its root functioned. So that was the underlying approach here. And really, behind all this, we wanted to go like, okay, so how are crops going to perform at different depths? What yield penalty do you get from that silt depth? And can we use that information to tell us something about how we can make decisions going forward? So in order to do that, we chose 4 crops, and we wanted crops that had contrasting seed size. So carrot, small, pea, medium, maize, large, because you've got this thing about seed energy reserves. So theoretically, a larger seed's got more seed reserve, and that will give it a chance to grow through the silt and work its way down through the silt to the soil. That's one thing about seed size. But also there's the root. So maize, for instance, has a nice strong root. You think it might be able to get its way through the silt down into the soil and get going. Whereas pea has a more shallow fibrous root than maize. So does it behave similarly or differently because of the silt? And then you've got this taproot that comes with carrot, but that is a taproot that is very sensitive to compaction. So it doesn't just grow right down through a compacted layer, and will that cope with silt? But also there's this question like, what if you don't do this seed germination thing? What if you just put in a transplant? Will that be better? And there are some transplanted vegetables within the system, so let's throw one of those in and just ask a question about the germination establishment. So that set up our background here. And we used a field in the Hawke's Bay that's commercially used for vegetable production, and it was a field that had a gradient of silt across it, all the way from like 10 to more than 60 centimetres all across it. And so what we wanted to do was to create a space where there was bare soil. We didn't want to run the machinery over it and compact that soil, so we did that by hand. So there's only 2 reps there for that bare soil. And then we had 4 reps of at silt at around about 20 centimetres and 4 reps at 40 centimetres, so 2 different depths. And we're interested, like 20 centimetre is sort of a level where you might go like, just turn it in. Don't worry about that, just turn that in. Whereas 40 centimetres you're going like, I don't want to turn that in, but maybe I take it off, or should I grow something on it? So that was how we set up the trial. In terms of getting the seedbed ready, this was land that very soon after the silt, the flooding faded away, and the grower could get on it with a tractor, they planted some ryegrass seed. And so there was some ryegrass seed on this for a little while before this trial was done on it. That ryegrass was sprayed off, and then we did the additional seed bed. So you've got the clumpy bit where we started, and then 2 passes with a rotary tiller, rotary hoe, at 3 to 5 centimetre depth to create a seed bed to plant in. And so here are our cultivars and our planting dates. So PAC 200 for maize, Narvit for carrot, Concept for the pea, and the Shogun transplants for the broccoli. And we planted them as we got availability of the seed and could get onto the land. So unfortunately, I do have some graphs. I've interspersed pictures with the graphs, but also I didn't choose them, so here we go. Also, just to note actually that the crops were grown at a commercial level, so all the pest and disease and weed management was using standard commercial practice. And the big issue here, while there was ryegrass planted in it, it was really, really patchy, and the main species there was willow weed, and that needed the most control. So that was that. Also, we took soil samples, and we used a soil sample analysis to determine the fertilizer to apply. And for that, we chose, we used the vegetable fertilizer handbook to determine what the fertilizer rate should be. And we used a level that meant that the silt was not limited by nutrients. So there was maybe a little bit more fertilizer going onto the soil than needed for just optimum yield, but the silt wasn't limited. So let's have a look-see at this. So here's the maize data. So I've got emergence and yield on there, and you've got the depths along the bottom there. And really, there was no issue in terms of the silt depth on maize emergence and population. And so you averaged about 81% emergence for the maize all the way across, regardless of silt depth. And the yields were not really significantly different either. Grown on bare soil, it averaged around 12 tonne, and there was a little bit of increase when it was grown at 40 centimetres to about 14 tonnes, but not statistically different. So the maize seemed to be doing pretty good, regardless of the silt depth. And then you've got the pea data. The pea data here in the emergence, at 20 centimetres, it was not different, not statistically different from when you were growing it on bare soil. So, but at 40 centimetres, there was a difference. It was lower. And that's repeated in the yield side as well. So even though you're growing at 20%, slightly less yield, slightly poorer emergence, germination, but not statistically significantly different. One of the things we noticed here with this pea crop was that it seemed to get going pretty good, but then it faded. And that's because the roots struggled to get through. And they managed to get through a little bit down to the soil in the 20 centimetres, but not in the 40. And that's where they struggled. And the thing is that the silt is sort of hypoxic, so it doesn't have a lot of oxygen sitting in it. And pea roots need good oxygen. And also they don't like compaction a lot. But the other thing was that they weren't producing nodules in the silt. So there's no nitrogen fixation there. There was nodules on the 40, on the 20, once it got through to the soil, you could find some nodules down there, but the bulk of the root didn't have any nodules, so it wasn't really doing its thing. So that's an issue to be considering there. The carrots, so the carrots just didn't like the silt at all. So let's say you've got around about 89% germination when it was grown on just soil, and at 40%, it's 29% germination. So the silt really affected the germination of the small seeds. And that's probably because you could see in that picture the structure of the silt was pretty crap. And when it was turned into powder by the rotary hoe, it's not a good space for small seeds to grow in. It's just not providing them with the oxygen and the soil cover that they need. So we didn't get good germination of that carrot seed. But also the yield was way down, but also the carrots that grew in the silt were malformed. And that's basically because they couldn't get through very well. So that was happening there. And then you've got the broccoli, and no effect, no effect of the silt on the broccoli, which is kind of interesting. So the not having to germinate seemed to be okay for the broccoli, and the fact that you had a root system that was already doing its thing, they seemed to cope better and grow through the silt okay. So we didn't get any difference in terms of the population that survived the transplanting, but also no real significant effect on the yield. Even though at 40 centimetres you sort of seemed to get a little bit of an uptick there, but nothing significant. So then what we did was we chucked all that data together, and what we wanted to know was is there some consistency in terms of the seed size and the root effect on the way that the yield declines with silt for these things. And so we redid that analysis and chucked that all together into one whole pile and ran that through. We allocated class to the seed, so the small seed was one class, medium seed another class, and so on. And really what we were interested, you take the yield at the zero silt depth, bare soil, and then you work out the percentage decrease. And what we found was that that was a good fit. That model described what was going on pretty well. And so you've basically got, for the small seed, for every 10 centimetre of silt depth, you've basically got a yield decrease of 25% for the small seed. For the medium seed, it's around about 15%. And that medium seed, you could argue that medium seed is similar in size to maize, but the root function is way different. So there is that side to be considered as well. The interesting thing is that nothing happening in the maize really. Maize does well. The interesting thing is the broccoli transplants, that there's a suggestion of this improved yield at the higher silt depth, which is something that's interesting there. So just to wrap up here, so if you've got silt and you've got more than 20 centimetres of silt, you want to grow a crop that has a large seed, so it's going to survive that initial germination phase, but also that it has a really strong root. So maize is a go-to there. That's one example of something. There's some other large seeded crops. You could go faba beans and so on, but and faba beans are not always as easy to get hold of as maize seed, especially after a flooding situation. So that's one thing. The other thing is that if you've got a soil depth that's maybe around a silt depth that's maybe around 20, if you want to grow other crops, you may consider just incorporating it, just tilling it into the soil and mixing it, because the physical structure of the silt for those smaller seeded crops is worse than the mixed up soil. So that's another option to do. Another thing to do is to consider transplants in some of these situations, and you can do that with some of these crops. So that's and in general, if you're going to keep silt on, then the small seeded crops are not something that you really want to be using. So that's a general conclusion and wrap up there. Just want to say thanks to all the people that helped with the funding, and there was SSIF, Strategic Science Investment Funding, in here as well. And just thanks to all the people that helped make it happen, provided the seed, and provided the fertilizer. So thank you very much, and any questions for Josh?